Hello friends, today we will learn about the basic operation of single phase transformer. It is used to control the voltage level. It can be used as step up or step down transformer. To overcome the losses, electricity from the generator is passed to the step up transformer. You can see in this picture, this is the distribution system. In this case, the voltage is being step up from the grid system and is received by a step down transformer and is supplied to the homes and the industries. Transformer is nothing but a set of coils magnetically coupled. The main thing is the physical basis is the mutual induction. Two inductive coils electrically separated but magnetically coupled. Now let us see this picture. This shows a transformer. For this we need to make an arrangement of ferromagnetic material, and it has a primary and a secondary. This is type of step down transformer from which we get electricity to our homes and industries. In this case, the primary has maximum windings and the secondary has minimum windings, so that the output voltage is decreased. The next is the step up transformer. This is generally used at the grid system. So the primary has minimum windings and the secondary has maximum windings, so we get the output voltage as large enough than the primary. Now look at this picture. This picture shows about step up and step down transformer, the voltage differences, how the voltage are different from primary to secondary winding in case of step up and step down transformer. Now next, coming to the transformer side, its operations and its basic constructions. It is made up of ferromagnetic material. It has primary and secondary winding. As you can see, V1 produces current I1 on the primary side and generates a voltage V2 on the secondary side by the principle of induction, that is the Faraday's law. First coil produces flux, circulates through the core, links to the second coil as the voltage is circulating. Flux is also circulating. There are certain assumptions like the windings should be lossless, permeability of the core is infinity, and there is no leakage. Now let me show you the basic operation of a transformer. This is the ferromagnetic core. This is the ferromagnetic core. It consists of two types of windings, primary winding and the secondary winding. Let voltage V1 is given across the primary winding and current I1 is produced. Similarly, voltage V2 is produced in the secondary winding with the current I2. V1 produces current I1 and generates a voltage V2 on the secondary side by the principle of induction. This is known as Faraday's law. V1 across the coil 1 produces phi m is established in the core. This flux, there is a linkage of flux from the primary side to secondary side, let it be phi m. Voltage induced in the primary side is E1 and voltage induced in the secondary side is E2. By Faraday's law, E1 equals to N1 d phi m by dt, or phi m equals to phi max sin omega t, where E1 equals to N1 omega phi max cos omega t. Similarly, E2 can be N2 phi omega phi max cos omega t. The total flux linking from coil 1 to coil 2 are same. Now if you see the RMS value, E1 equals to 2 pi by root 2 N1 F phi max, which is equals to, it's a very popular formula, 4.44 N1 F phi max. Similarly, E2, the RMS value of E2 will be 4.44 N2 F phi max. These are very important concepts on the part of students to learn and to remember. Now let us see the transformation ratio. Transformation ratio gives a relation between the output voltage, induced EMF, number of turns and the current, as V1 by V2 equals to E1 by E2 equals to N1 by N2 equals to I2 by I1. This is for an ideal transformer. The practical transformer consists of a ferromagnetic core having primary and the secondary winding. These are a set of windings used to make a transformer. You can see inside a radio in the power system circuits. They're used everywhere. We can, in general electronic devices, we use transformer of 5 volt or conversion from 5 to 12 volt or 12 volt to 20 volt, like that. Taking a closer look, we will find that transformers are made of thin sheets. These are generally known as the laminated sheets. This process is called lamination. It is used to avoid eddy current loss. Now you know about the basics of eddy current. Coming to the next topic is the types of transformer. It can be of core type or shell type. The difference between the two is, in case of core type, winding surrounds the core, and in case of shell type, the core surrounds the winding. We get two different types. One is E type and one is I type. The combination of E type and I type gives a different view of the transformers. So the losses of transformer and various things we will study in the next chapter. Thank you.